Welcome to the ultimate journey into the heart of one of the universe's most fascinating and mysterious phenomena: black holes. Black holes push the limits of our understanding, where gravity reigns supreme and the very fabric of space-time twists and bends. In this video, we'll dive deep into what black holes are, how they form, their various types, and how they warp the laws of physics. We'll explore their impact on the universe, the paradoxes they present to modern science, and the mind-bending theories about what lies within and beyond these cosmic giants. Let's start by defining a black hole. In simple terms, a black hole is a region in space where gravity is so intense that nothing, not even light, can escape. It's like an invisible trapdoor in the cosmos. Black holes are essentially objects compressed into a point with infinite density, known as a singularity, surrounded by an invisible boundary called the event horizon. The singularity holds all the black hole's mass in an infinitely small space, while the event horizon marks the point beyond which nothing can return. To understand black holes, we need to touch on Albert Einstein's theory of general relativity. General relativity suggests that massive objects warp spacetime, causing it to bend around them, and this is what we perceive as gravity. For everyday objects, this effect is minuscule, but in the case of a black hole, spacetime bends so steeply that it essentially folds in on itself, creating a region where gravitational pull is inescapable. This unique curvature of spacetime defines a black hole and its immense gravity, which is so strong that it traps everything that crosses its boundary. Black holes form in several ways, but most originate from the collapse of massive stars. Stars are powered by nuclear fusion, which balances the inward pull of gravity with outward radiation. However, when a star several times larger than our Sun exhausts its fuel, it can no longer support its own mass. Gravity takes over, leading to a catastrophic collapse called a supernova. If the core is massive enough, it collapses into a black hole. Stars similar in mass to our Sun become white dwarfs or neutron stars instead, as they lack the required mass to become black holes. The formation process depends on the mass threshold. Stars roughly 8 to 20 times the mass of the Sun may leave behind neutron stars, while stars above this range often collapse directly into black holes. Black holes are not one-size-fits-all. They vary vastly in mass and size. The main types are stellar mass black holes. These black holes form from the collapse of individual stars and range from a few to around 20 solar masses. They're relatively small, but still incredibly dense. Intermediate mass black holes. These range from hundreds to thousands of solar masses and are thought to form through processes like the merger of multiple stellar mass black holes. However, they're harder to detect and are still a mystery in many respects. Supermassive black holes. These giants reside at the centers of galaxies, including our Milky Way. They are millions or even billions of times the mass of the Sun. Despite their size, their formation process remains an active field of research. Some theories suggest that they form from the collapse of massive clouds of gas or grow by consuming surrounding matter over billions of years. Ultramassive black holes, UMBH. There are also theoretical ultramassive black holes, exceeding even the size of supermassive black holes. These titans may have grown by consuming smaller black holes or by merging with other supermassive black holes during galactic collisions. The anatomy of a black hole is unique and consists of several layers. Event horizon. This is the boundary beyond which escape is impossible. The event horizon is not a physical surface, but a point in spacetime where escape velocity equals the speed of light. Photon sphere. Just outside the event horizon is the photon sphere, where light orbits the black hole. Due to extreme gravitational bending, photons can be trapped in a circular path around the black hole. Accretion disk. Surrounding the event horizon, the accretion disk consists of matter spiraling into the black hole. As it falls inward, it heats up to millions of degrees, emitting X-rays and other radiation, which makes it observable. Singularity. Deep within the black hole lies the singularity, a point where density becomes infinite and the laws of physics break down. Scientists have yet to fully understand this region, as it defies all current theories. Although black holes are invisible, astronomers have several ways to detect them. Observing the motion of nearby stars. By tracking the motion of stars orbiting an unseen object, scientists can infer the presence of a black hole. X-ray emissions from accretion disks. The high-speed collisions within the accretion disk create intense X-rays that reveal the location of a black hole. Gravitational waves. When black holes collide, they produce ripples in spacetime. Instruments like LIGO detect these waves, confirming the presence and merging of black holes. In 2019, the Event Horizon Telescope provided the first-ever image of a black hole located in Galaxy M87. This groundbreaking image shows a glowing ring of gas around the event horizon, marking an achievement in astrophysics that confirms decades of theoretical predictions about black holes. One of the biggest puzzles surrounding black holes is the information paradox. Quantum mechanics dictates that information cannot be destroyed, yet black holes seem to consume everything that enters. Stephen Hawking proposed that black holes emit Hawking radiation over time, which means they slowly lose mass and could eventually evaporate. But if a black hole vanishes, what happens to the information about what fell in? This paradox remains unresolved and represents a clash between quantum mechanics and general relativity. Black holes are among the most mysterious objects in the cosmos, challenging the boundaries of physics and human understanding. As we continue to study these enigmatic phenomena, they may unlock answers to the biggest questions about space, time, and existence itself.